In this video, we will see how to calculate probabilities for binomial distributions. So to access the functions that will help us do that, we would need to access the distribution app here, which is second vars, and once you're in there, scroll down to find binomial. So go down and it's probably A is for binomial PDF and B is binomial CDF. And which one do you use when? So binomial PDF probability distribution function is when you're looking for the exact value of the number of successes, and binomial CDF cumulative distribution function is when you're looking for less than or equal to or greater than or equal to. You have some kind of a direction, so you're looking for the cumulative values is when you use binomial CDF. So we'll take a look at an example. Let's go to our example here that we will be using. So it has been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. And we have 20 adult workers who are randomly selected. So we'll do part A on the calculator, which is find the probability that 12 of them have a high school diploma but do not pursue any further education. So how do we know if this is a binomial experiment? Well, let's see. We do have fixed number of trials, as in 20 adults, and each one has fixed probability of success, which is 41%, 0.41. So for that reason, this is a binomial, and let's see the summary of it actually. So we let X, our random variable, be the number of workers who have high school diploma but they do not pursue higher education. Then the possible values that you could have is that you either have a 0 worker or 1 or 2 or all 20 of them in our selected sample that have high school diploma but do not pursue higher education. What we are interested in is finding the probabilities of maybe, let's say, 2 of them pursuing higher education, rather not pursuing higher education out of 20. Maybe we are interested in 10 or more of them who have high school diploma but do not pursue higher education. So those are the kind of questions that will be answered by the calculator. So we have n equals 20, and probability for each trial, in this case each worker, is 0.41. Symbolically, we would say X has a binomial distribution with 20 trials, 0.41 probability for each trial. So let's go to our calculator and see what we need to do. So we are interested in looking for exactly 20 of them who have high school diploma but do not pursue further education. 12 of them out of those 20. So the exact probability would mean that we are going to go to PDF, hit enter, trials, 20 of them. We have 20 workers, which are our trials. Probability in each trial, 0.41. What are the X value we are interested in? We are interested in 12 of them out of the 20. So 12, come down to paste and enter, and hit enter again. And it will give you that probability of 0.417, which is roughly 4.2%. So we could say the probability of 12 of the workers out of 20 who have high school diploma but do not pursue higher education is 4.2%. And in fact, let's take a look at the second part of the problem also to use CDF. So this time find the probability that at most 12 of them. So you are interested in getting the probability for 12 or less number of people who have high school diploma but do not pursue higher education. So we go back to our calculator. So because there is direction, well, first let's get to our binomial CDF function by going to distribution, go down to B, enter. So we are looking for cumulative probabilities from 0 to up to 12, it said. Trials again is 20. Probability of each trial, 0.41. X value is still 12, but we're using CDF, okay, as in so cumulative of up to 12. Paste and enter. And because it's cumulative, the chances are it's going to be higher than the exact 12 that we had, which it is. So it's much higher. So the probability of up to 12 workers who have high school diploma and do not pursue higher education is 97.4%. And that's how you calculate probabilities for a binomial distribution using TI84.